Hello, dear class 5 students, the smartest students. This is your science teacher. Welcome back. Okay, so we are in the third chapter, that is matter, right? Matter. Everything around us is a matter. Anything that occupies and that has a mass and occupies space is a matter. Yesterday we have studied about solid, liquid, gas, right? And the classification. Okay, we have started with the classification of matter, where it was divided into two parts, right? Pure, pure substance and a mixture, right? And in the pure substance, we got like elements and compounds. So we are done with that, and today we will start with the mixtures. Clear? Mixtures. Mixture, mixing means anything. Like if we mix two or more substance, then that becomes a mixture. Clear? Example, let's say salad. Okay? Example, salad. Any form of salad. It can be a fruit salad, it can be a vegetable salad, it can be an example of mixture. And this mixture, we have two parts. Okay? It's divided into two types. That is homogeneous mixture and heterogeneous mixture. Clear? Okay. So mixture, we have two types, that is homogeneous and heterogeneous. Clear? Homogeneous and heterogeneous, these are the two types of the mixture. Now, a mixture is not a pure compound. Clear? Because see, salad is not a pure compound. We are mixing. Okay, let's just take an example. Let's say you have added like carrot, you have added green chili, you have added some green, like green leafy vegetables, which are very good source of iron, protein, energy giving foods. And then let's add some tomatoes. Clear? But it's a mixture. It's not chemically joined, right? You can separate. If you are told to separate the chili from the salad, will you be able to separate? Yes, it'll take time, but you can separate the chili from the salad, right? But what about the water? What about water is, yesterday, as I've explained, water is made up of hydrogen. How many hydrogen? 2 hydrogen. And how many oxygen? 1 oxygen. Okay? 1 oxygen atom. So water is a pure compound because anywhere, if it's like in Kohima or if it's in Dimapur or Mochung, like anywhere it's the same. It's made up of the same atoms. Clear? Same 2 hydrogen atoms, 1 oxygen atom. Clear? And if you are told to separate this hydrogen and oxygen with your hand, will you be able to do? No, because water is a pure compound. Clear? Now, but this, because in water, they are chemically joined. These 2 hydrogen and oxygen, they are chemically joined. Clear? But in salad, it's a mixture. It's not chemically joined. That's why you are able to separate the chilies. You are able to separate, if you are told to separate the tomatoes, you can easily pick the tomatoes, right? So water, this salad is an example of mixture. Okay, so now from this mixture, let's talk about homogeneous mixture and heterogeneous mixture. Clear? This homogeneous mixture, it's okay, it is a mixture where the properties and composition is uniform. Okay? Properties and composition. Okay? And composition are uniform all throughout the mixture. Clear? Where the properties and composition are uniform. Uniform means same, right? The school uniform. In your school, all of you have the same uniform, right? So its properties and composition are uniform. Okay, I'll write the uniform in the bold letter. Okay, uniform. Example, I'll give you an example. Okay, science, you learn it better by giving examples. Clear? So now, see, salt, you all know, right? Salt. Now, let's take water. Okay, if you put some salt in water, you dissolve it, will you be able to identify which one is salt, which one is water? It's the same, right? You can't differentiate. So in that way, it is uniform, right? Or you can try with sugar as well. If you dissolve in water, you will not be able to identify which one is water, which one is salt, which one is sugar, because the properties and composition are uniform all throughout the mixture. So this is all this, like if it's uniform, then it is under homogeneous mixture. Clear? So you are clear with homogeneous mixtures? Okay. Now let's start this heterogeneous mixture. It's just the opposite. It's also a mixture. It's not a pure compound. It's a mixture. But this heterogeneous mixture, it is properties and composition are not uniform. You have to write the same thing, okay? But just you have to add one thing here in the definition. It is not uniform. Clear? Not uniform. Okay, I have explained that water and oil cannot be friends, right? Water and oil, they are never friends because they don't dissolve, right? You can just try, like in water, if you put some oil, then would they act like a salt and water? No, right? Because they hate each other. They're enemy. There. So now in heterogeneous mixture, you have added already oil and water. Now you'll be able to identify in the mixture that this is oil, and this is a water, right? Because the properties and composition are not uniform. Clear? So now we are done with homogeneous mixture and heterogeneous mixture. We'll go to the next topic. That's a very interesting topic. That is changing states of matter. Clear? Okay, students, next topic is changing states of matter. Matter, we have studied that we have like solid, liquid, and gases, right? We have studied how the molecular forces, how the molecules behave, how the molecules move in solid, in liquid, and gas, right? So now we'll study how the changing states, okay? So now from solid to liquid. From solid, okay? From solid, if changes to liquid, then what do we call? That is melting, okay? Now, let's say all of you like ice cream, right, in school. So ice cream, it will be in a solid form. But it absorbs heat, and what it converts to a liquid, right? So this comes under melting. Clear? Ice cream in a solid form will convert to a liquid water. Right, so that is melting. Clear? Now, what about liquid to gas? Liquid to gas. It will be, liquid to gas will be evaporation, right? Evaporation. Now, if you just boil the water for a long time, okay, what will happen? It will convert to a steam, right? Now, or if you just keep it, maybe like in a summer day, during the hot summer day, it will automatically convert into a gas, right? Because it will absorb heat from the atmosphere, right? And now, now in reverse, okay? From gas to liquid, we call it as condensation, okay? Condensation. And one example, like from gas to liquid, it can be also in the form of rain. Clear? Now, from liquid to solid, okay? If you just keep some water in an ice cube, and if you just keep in your refrigerator, it will change to solid, right? So that is known as freezing. Okay, so you just have to keep, okay, what melting is? Okay, solid to liquid on absorbing heat, right? And then from liquid to gas, it is known as evaporation, steam. Clear? Now from gas back to liquid is known as condensation. Clear? Where there will be a withdrawal of heat. Now from liquid back to solid, where there will be a withdrawal of heat, it will be a freezing. Clear? Okay, so you have to remember these terms. Clear? Okay. Next topic would be physical change and chemical change. And that is a very important topic which you'll study even in your further classes till class 10, till 12 if you take up science. Okay, students, next topic is a physical change. Clear? Changes, how many types of change we have? We have two types of change, physical change and chemical change. Clear? So first we'll start with a physical change. Physical change is a type of a change, okay? I'll repeat, physical change. It's a type of a change where you will not get to see any new property. You will not get to see any new substance. And that is known as physical change, okay? I'll show you a small demonstration. I have a paper with me right here, right now, okay? So now this paper, if I just crush it, clear? It's still a paper, right? Did I see any new property, new substance? No. It's just it's just a paper, clear? No new substance formed, it's just a paper. Now, if I tear it, still a paper. So this falls under this physical change. So the definition is very simple, a type of a change where no new substance, where no new properties are formed is known as physical change. Clear? You can just give this example, you can write, clear? Okay, now the second type of change would be a chemical change. Chemical change. Chemical change. Students, chemical change is a change, it's an opposite now. It's a change where you'll get to see new properties and a new substance. Clear? And see, now, okay, this one you can, but be very, you can try at home, but be very careful, okay? You should be careful because you have to use a lighter or a matchstick, okay? So you can, without you doing, you can tell some elders at home to do and show you. Clear? Okay, because you should not play with matchstick or any fire stuffs. Clear? So if this paper, if I burn this one, it will turn to a what? A white powdery thing, and then the results, you'll not get a paper anymore, right? The results you'll get, it will convert into a white powdery thing. So now there is no paper anymore now. Clear? Because it has been converted to a white powdery substance. So that's an example of a new substance, new property. Clear? Burning a paper, the results, you're not going to get the same paper, unlike physical change. Here, you're getting new substance and new properties. So a type of a change where you get to see new properties and new substance are known as a chemical change. Clear? So students, we are done with physical change and chemical change, and we are done with this chapter, okay? So in this chapter, we have studied about the matter, we have studied about the atoms, molecules, clear? Two or more atoms combine to form molecules. That means the atom is the smallest one, clear? The tiniest one. And then we have studied how the arrangement in the solid, in liquid and gas, right? In the solid, they are tightly packed, close friends, bonded, right? It's very hard to break their friendship, clear? And they have a definite shape and definite volume. And in liquid, they take any shape of its container. If you keep a liquid in a solid container, it takes the shape of a solid container, right? If you keep the liquid in a rectangle shaped container, it will take the shape of a rectangle container, right? And then gas. The gas are the molecules inside the gas, they move like crazy, right? Okay, and we have studied the classification of matter, pure, mixture, elements, compounds, and then we have completed with the heterogeneous and homogeneous mixture, right? And the changing state from solid to liquid, keep all that in mind, and you can note down, okay? You have to go through and refer the textbook, clear? And the last thing that we have covered in this chapter is a changing chemical change. And we have studied two types of change, physical change and chemical change. Clear? So this chapter is very important. So you have to go through again, and whatever examples I've given, you have to visualize it. Clear? So now what we'll do is we'll see some exercise question like true or false. In that way again we'll learn more. Clear? So we'll see some exercise question. Okay, so students, my dear class 5 students, so we're done with the chapter. So let's play a game. Okay, this is a true or false game. So wherever you are at home, you can respond. Okay, so now the first one, atoms are made up of molecules. Atoms are made up of molecules. That's a true or false? See, molecules, 2 or more atoms combine to make a molecule. Clear? 2 or more atoms gives molecule. That means they are saying that atoms are made up of molecule. This is a lie, right? Because atoms is the tiniest one. Atom is the smallest one. Then how atoms are made up of molecule? This is a lie. So this is false. Yes, I know, like all of you said false. Okay, now salt is a mixture. I have given a difference between a mixture and a pure compound, right? So now salt. Salt is this one, okay? NaCl. NaCl is a salt. Now, like the salad, where you can easily pick, or salad is a mixture which is not joined chemically, right? Where it was a mixture. Now, salt is not a mixture because it is a compound. NaCl, you cannot, okay, Cl, you can just pick it from your hand? No. If you just see, if you at home, if you just see the salt, you cannot make a difference which one is sodium, which one is chlorine, because they are chemically joined. Clear? It's not salt and salad is completely different, right? So salad is a mixture, but salt is not a mixture. So this is also a lie. So we'll write false. Now, solid molecules are closely bound. True. Clear? Because in solid, the molecules, they are all tightly packed, best friends. It's hard to break the friendship because they are all tightly packed, joined. So this is a true. So solid molecules are closely bound. Let's write true. Now, molecules of gas move freely. This is also true because in the gas, the molecules, they move like crazy. Do you remember yesterday we have discussed this? The molecules in the gas, they move crazy. Okay, so now we'll write this one, true. Okay, now the last one for a true or false. Liquids have fixed shape. No, right? Because if you put any liquid in any kind of shape, it will take the shape of its container. Remember the rectangle in a solid container example I've given? Or if you just spill the liquid or water in a floor, it will take the shape of the floor, right? That means liquid have no fixed shape. It can take the shape of anything, any container. Clear? So liquid have fixed shape. This is a false. Okay, now I've given here 2 additional questions to end this chapter. Clear? So we have to write here what kind of change this is, okay? Burning of paper. Burning of paper, will you get the paper, the result? No. There will be a new substance formed, so it will come under chemical change, okay? There's no chemical change. Clear? Now, tearing of paper, what results you'll get? It will still be the paper, right? That means no new substance form, that comes under physical change. Physical change. And there are many interesting questions in the exercise. You can try that, okay, students? That's an assignment. And you are class 5 students, you're all smart. I'm sure right after watching this video, you're going to do that exercise, okay? So thank you so much. We'll continue with another interesting chapter in the next class.